off last time. So just to give you guys a heads up here on one note in the content library, I copied the notes from last time and to a separate tab or separate page here and relabeled it with today's date because we're going to kind of continue with using some of the examples we used last time. So if you're using your own notebook, you may want to go back and just add on to the things that we did last time rather than having to recopy things, since we still had to go back and talk about domains and ranges, right? That's what we'd left off doing. Okay, so I'm going to use the same examples that we did at the end of the lesson last time as our examples for doing domain and range. So you don't have to recopy these as new example problems. You can just go in and add on to the notes from last time. You guys know what I mean? Which is what I'm doing here, right? Again, you'll notice that I made a new page for today's notes, but it's really just me copied the notes from last time, and we're going to add on to it. Okay? All right. And while I wait for a little bit for Reese to get here so we can kind of not start without her, I want to make mention of a couple of things. So last time we did the homework quiz in class. A couple of people I noticed didn't submit their responses to the PowerSchool Dropbox. If that was the case, you got an email from me today letting you know that I didn't receive that. And to just email me your homework quiz filled out. So if you just make sure that you check today to see if that was you or not. Okay, there was a handful of people that I think missed that last step there. Okay, no big deal, right? It's the first week of school. Nobody's getting bent out of shape about anything, but I do need them to submit it so I can grade them and put a score in the grade book for you. Okay. And then a reminder again about the syllabus sign-in sheets, that if you had problems with that, check Net Classroom to see if your submission was good or not, and if it wasn't, because you sent me the blank one, or the file was corrupted or whatever, or it wasn't filled out all the way, there'll be a missing in Net Classroom for your syllabus, in which case just resubmit. I opened the Dropbox up again, so you should be able to resubmit without any problem. And try to take care of that by Sunday midnight. Okay? All right. So today I'm going to try to work in like this green color maybe, so to differentiate it from the colors that I used last time, just so you can see what the new stuff is. Easier if you go and look at these notes. Everybody okay with that plan? Okay. So today we're going to talk about determining domains and ranges for these relations. The first thing that I want to do before I start thinking about the domain and range is look at my relation and decide if it's finite or infinite. Because that's going to that'll determine what kind of notation I'm going to do when I write the set for my domain and range. So before I get started on writing the domain and range, I want to think about what kind of notation do I need to use here. So if I look at example A here, this relation, is this a finite relation or an infinite relation? How many ordered pairs are in this relation? 4, which means it's not infinite, right? Because there's a specific number of ordered pairs in there. Everybody agree with that? So since this is a finite relation, I know that the domain and range are also going to be finite. So I know that I can just make a list for the domain and a separate list for the range. Is everybody okay with that rationale? Okay. So remember, the domain is the set of which coordinates? the x's. So in this case, we would write the domain as 1, 2, 3, 4. And the range is the set of which coordinate? The y. So here we write the range as the list 2, 3, 4, 5. In the situation where the relation is finite like this, writing the domain and range is pretty easy, right? You're just copying down a list. So if we look at example B, again, we notice that we have a finite relation. So we can just write our domains and ranges using a list. What should I write down as my domain for B? Who can tell me? Go ahead, Joseph.
1, 2, 3, 4.
Very good. Though again, those are just the x coordinates. And the range would be? Okay, very close. What's the issue with 2, 3, 2, 5? We can't repeat elements, so how many times do I write the 2? Just once. Does it matter the order in which it goes? It does not. So any order 2, 3, 5 should be the range. Everybody okay with that? Okay. Let's look at example C. Again, this is a finite relation. So again, the domain and range can just be a list. Who can tell me what the domain would be for C? Just one, right? Very good. Because that's the only x coordinate that's used. I still need to make sure I write those little set brackets around the number 1. But it's just one thing in the domain. And what would the range be? 2, 3, 4, 5. So far, so good? Okay. Let's look at D. Is this a finite or infinite relation? Finite, because how many ordered pairs does this really represent? 3, right? Because there's just 3 arrows drawn. Each arrow represents an ordered pair. I have exactly 3 arrows. I have exactly 3 ordered pairs. That means that this is a finite relation. So again, the domain and range should be easy to write because they'll just be lists. What will the domain be here? 1, 2, 3. Just the things inside of the D circle. And what would the range be? -2, 0, 1. Just the things in the R circle. It's as easy as that. Everybody's okay there? Okay. Let's look at the next one. So again, this is another finite relation. What would the domain be? 1, 2, 3. Even though 3 doesn't get used, it is drawn in as part of the domain, so it needs to be listed as part of the domain. And the range should be -2, 0, 1. Everybody okay with that idea? Okay. And then on to F here. Again, another finite relation, so the domain and range should be relatively easy to write. What would the domain be? 1, 2, 3. Does it matter that the 1 has 2 arrows going out of it? Not in terms of writing the domain, it doesn't. And the range should be?
-2, 0, 1.
Yeah, -2, 0, and 1. Does it matter that some of those numbers have more than one arrow going into them. Not for writing the range, it doesn't. Everybody so far so good? Okay. Now, for G, what piece of information is missing that you would need to have in order to write the domain and range? The coordinates for these points, right? But if you had the coordinates, this would be easy to do. I'm going to skip it because I don't feel like writing in coordinates for something that right away we seemed pretty obvious that we saw what we would have to do the domain and range for this. That if I knew the coordinates where these points were at, I just list the x's and list the y's, because this is clearly a finite relation, right? Because there's just, 5 points in it. Everybody's okay there? Okay. Where this gets trickier is something like I. Because how many points make up I? Infinitely many, right? Remember from geometry, how many points lie on a curve or a line? Infinitely many, right? That was one of the axioms you guys would have learned in, the first couple of weeks in geometry. So we need to use a different notation to describe the domain and range, and a little bit different approach to describe the domain and range than what we did previously. Everybody's okay with that idea? Okay. So the notation that we're going to use to describe a domain and range when we have an infinite relation like this is going to be using the interval notation. Do you guys remember? Have we done interval notation? Okay. Well, let's start with an inequality because that's a little bit easier to start with. And then we'll translate that into an interval notation afterwards, okay? Okay. So we'll start by just writing an inequality describing the range of values that x can have. Sound good? Since there's infinitely many of them, we can't list them all, so we'll describe it as a big range of values. So if I look at this function, I want to find the place on the function that's the furthest to the left, which would signify the smallest x coordinate. Is there a place that's furthest to the left on this function? Well, it's kind of this arrow that's pointing down and to the left, right? Now, does this refer to a specific point if I have an arrow at the end of the graph? No, right? It tells us that graph keeps on going forever. So what number would I call, would I assume the x coordinate is if it's going left forever? Negative infinity. Everybody's okay with that? So if it's going to the left forever, that's negative infinity. And negative infinity isn't a real number, so it can never be an or equal to. But I know that x has to be bigger than negative infinity. Everybody's okay with that? And then I'm going to identify the part of the graph that's the furthest to the right. That would be the biggest x. Notice the same thing is happening here, right? We have an arrow that's pointing to the right and up. So the biggest point on the graph would be positive infinity. And we know all the x's have to be less than that. Everybody's okay with that idea? One more thing that we should have mentioned that I took as an assumption going on here is between the point furthest to the left and the point furthest to the right, the graph is connected all the way in between. If the graph wasn't connected in between, we'd have a little bit more work to do. We'd have to look at these as two separate pieces of the graph. But because it's connected all the way through, it doesn't matter. If we don't have an example where that happens, we'll write one up after we've kind of burnt through these. But that's a little bit more complicated. Okay, so this is an inequality. You can represent a domain or range with an inequality, that's fine. To translate this into an interval notation, what I'm going to do is I'm going to take the lower bound, and I'm going to take the upper bound, and I'm going to write them like an ordered pair with a comma in between them. If the inequality is a strict less than or greater than, I use a parenthesis. If it was an or equal to inequality, it would get a bracket. So an interval can look a lot like an ordered pair, but because we're listing it for a domain, we know from context the domain is not an ordered pair. A domain is a set. It's a range of values. That would not represent a point, rather the same, it would convey the same information as that inequality. Is everybody okay with that idea? To do the range, we're going to kind of approach things the same way, but instead of identifying the point that's furthest to the left or furthest to the right, we're going to identify the point that's the lowest and highest on the graph, because the range is about the y coordinate. So we're concerned with like how low and how high. Everybody's okay with that idea? So again, if I look for the lowest point on my graph, I have the arrow pointing down. So the lowest point would be negative infinity, right? Because we're going down forever. And then if I look for the highest point on my graph, that would be the arrow pointing up, so positive infinity, because we're going up forever. So I can say that negative infinity should be less than y, which is less than positive infinity. Or if I wanted to translate this into an interval notation, and typically in an algebra class like this one, we prefer to write our domains and ranges using interval notation because it's less symbols. More often than not, in mathematics, we invent notations that allow us to write down less stuff. It just is kind of the convention inside the discipline. Like we don't want to write prefer to write down less symbols than more. Don't ask me why, but that's just kind of the way we do things. Everybody okay with that idea? Okay. To do this next example, I'm going to have to include some coordinates here. So actually, let's use the green color so we can tell that I did this later. So I'm going to just draw in those 4 points so that we're able to handle this one. I'm going to do that just to make a little bit of space here between my examples so it doesn't all run together. But we're going to start the same way. Again, we notice that this is an infinite relation because the graph is connected, right? So I'm going to start by identifying the point that's furthest to the left in order to do the domain. That point would be negative 1, 0. So the x-coordinate I'm interested in is negative 1, right? So that's going to be the smallest thing in my domain. And now, should this be a strict less than as I've written it, or should it be less than or equal to? Do I have a point on the graph that actually has the x-coordinate of negative 1? Yeah. I do, right? It's this point right here. So that should definitely be or equal to, because we have a point in our relation that has an x-coordinate of -1. So -1 is a value for x. So we need that or equal to there. What's the point that's farthest to the right?
1, 0.
1, 0. So the x-coordinate is the part I care about. So again, I can say then x is less than, or -1 is less than or equal to x, which is less than or equal to 1. Let's translate this into an interval notation. So I'm going to take the lower bound, that's -1, comma the upper bound, that's +1. And now because these are or equal to inequalities, I'm going to use a bracket instead of a parenthesis. So that's how we differentiate the difference between a less than and a less than or equal to using interval notation, is we use a parenthesis for less than and a bracket for less than or equal to. So far, so good? Okay. Let's do the range now. So for the range, we're caring about the y-coordinate, so we care about up and down. So we're going to start by finding the lowest point on the graph, which is 0, -1. And the number that we care about here is the y-coordinate. And because we have a point that actually has that y-coordinate, I know it's going to be -1, less than or equal to. And because we're doing ranges, we're doing y's now instead of x's. And the highest point in this function is 1, 0, right? So we have that y is also less than or equal to +1. Is everybody okay there? And when I translate that into an interval notation, it's the same thing. So at this point, you might be asking yourself, are the domains and range always the same? Because we've done 2 examples where they were the same, right? Or at least these infinite situations. Yes, sir?
Why would it be
Because I wrote down the wrong coordinate here. That's why, yeah, you're absolutely right. That should be 1, 0, or 0, 1 there. Obviously, 1, 0 should be this location here, right, where you've gone right 1 and then 0 up. That spot is definitely 0 over and 1 up. I just wrote down the wrong number, but you're absolutely right in saying something was fishy there. I wrote down the wrong point for that location. So thank you for pointing that out. Make sure I give people credit. Tyler, right? Yeah, so thank you, Tyler. That helps. I'm sure that you weren't the only one going, what's fishy with this? Because I did see some strange looks from people, and I was like, why are they looking at me strangely? We just had this a second ago. Everybody was answering this question pretty much without any hesitance. And then I get the strange looks for this. I was like, why are you looking strangely at me? So that makes sense. Okay. So thank you again for that correction. Good. Everybody okay there? So I think we had a couple more examples still that we need to run through, and then we'll do some more specific ones. I'll probably just focus on these infinite situations where writing the domain and range is a little bit trickier than the finite one where you're just basically making a list, right? It seemed like that was no big deal. These ones can be a little trickier. Okay, this next example, remember here this relation was this diagonal line plus this extra dot here, right? We had this one extra point. But we're going to start the same way. We're going to say, okay, what's the leftmost point? Well, we have an arrow pointing to our left. So we have negative infinity. And the rightmost point is the top arrow to the right, so positive infinity, and they're connected in between. So the domain is just the interval negative infinity to positive infinity. And the infinities always have a parenthesis because, again, you can't be equal to infinity. It's not an actual number. So nice way to kind of think about that is you don't ever have to go, should that be a parenthesis or a bracket? The infinities are always parentheses. Always, 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 always. Numbers, you have to think about a little bit, but an infinity always is a parenthesis. Okay? So the range. What should the range be? Yeah, it's going to be the same thing, negative infinity to positive infinity. Very good. Why did that extra point not matter?
Is now with the arrow with the line.
Well, no, not exactly. The point, or the reason that point doesn't matter, is because this point has the same x-coordinate as this point. So the x value for that straight point is covered on the line. And then, like, this point over here has the same y-coordinate, right? So there's a point on the line with the same y-coordinate as that extra point. So we didn't have to worry about that extra point at all because its x and y are used by some point on the line. So we covered it by just worrying about the line, and we didn't have to worry about that. We'll do an example in a minute where that's not the case and what that would look like, okay? But I want to finish up with these ones that we've already written down, and we'll look at an example where, like, a straight point definitely makes a difference. Okay. So here, we had our y equals mx plus b, right? And we said, okay, that just looks like a graph that looks like this kind of a line. Is this problem really any different than the problem before? If I have a diagonal line like that, what's the domain and range always have to be? Yeah, negative infinity to positive infinity for both of them. Is that a stretch or a question back there? Just a stretch? Okay. No problem. I'm just checking. I didn't want to leave you hanging if you had something. Okay. This one, remember how we talked about this being a circle? It's actually exactly the circle here in J. It's a circle that's centered at the origin whose radius is 1, which is exactly what J is. Would not be my expectation that you would be able to do a domain and range for an equation like that. That I'm not confident that everybody would know on sight that that is a circle. Now, if I gave you the graph and the equation, I'd expect that you could handle that, because I don't think the equation really matters at that point if you know what it looks like. But I wouldn't expect you to given an equation that you wouldn't know immediately what the graph looks like, to be able to do a domain and range for it. Not for a class like this. Okay? So I'm just going to skip that last one from the example. Okay? And let's do some things that maybe have some tricky domains and ranges here.
So,
Yes.
so in an infinite domain, it's always going to be negative infinity or positive infinity?
No. And we'll do some of these in the tricky examples now.
Okay.
Yeah, so that's a good question, right? So far on these infinite situations, the domain has been negative infinity to positive infinity, but it hasn't, right? Go back and remember the circle where it was a subset of that, right? We just went from -1 to +1. So we'll do some more examples here to show that like you can get some unusual results. So the domain, the point furthest to the left has x coordinate -infinity, right? If I go furthest to the left, that involves the arrow pointing to the left. So my x coordinate would be -infinity. Everybody's okay with that? Now let's identify the point furthest to the right. It's this point at 4, 4. So the x coordinate there is 4. Should I use a parenthesis or bracket here? Is there a point on my graph that has the x coordinate 4? Yes, so I should use the bracket for the 4. Is everybody okay there? Okay. Let's do the range now. What's the lowest point on my graph? -infinity. Good. And the highest point again is 4. And that 4 should have a bracket because it's the same point that the end of the, or the rightmost point was. Everybody's okay there? Let's do another. Okay. Offhand, does anybody know the name for this shape of a graph? You may have seen this in your Algebra 1 class. If you didn't, that's okay. This is just an aside. Not an expectation that you know the name for a graph whose shape is this. Starts with a P. It is a parabola. Some of you may have recognized that name before, and if you didn't, that's okay. Again, some of you may have seen that in your Algebra 1 class, and some of you might not have. We talked about why those Algebra 1 classes might differ, particularly if you took it as an 8th grade where you missed, 2 or 3 weeks of school at the end of the year because you graduate early or whatever. Okay, so the domain here, we're going to worry about the leftmost point, which would be be the left arrow, right? So it's going to be negative infinity. And the rightmost point? Positive infinity. Good. Megan, was your hand up there for a moment? Why was it negative? Because that arrow is pointing to the left and up. Remember, we're talking about the x-axis. The left side of the x-axis is where the negative coordinates live. We're not worried so much about the up and down. That's about the y. So you got to be careful when you're doing the domains. You're just worried about left and right. Even though it's pointing up and to the left, the up part doesn't matter for the domain, just the left part. Does that feel good? Good question. Again, it's easy to get hung up on like, oh, it's pointing up. Well, it's also pointing to the left, and that matters a lot, right? Okay, everybody feel okay on the range now? Feel okay on the range. Feel okay about the domain. Let's do the range. What's the lowest point on this graph? Here, 0, 0, right? Okay. So the y-coordinate there is 0. Should I use a parenthesis or bracket? Bracket, very good. And the highest point on the graph is positive infinity. It's either one of these two arrows. The fact of the matter, though, is both of them are pointing up. So it's positive infinity. And the infinities always have a parenthesis and never a bracket. Are we okay here? Okay. Maybe just a couple more and then we'll transition into something else. So the first thing that I want to notice is that this graph is not connected, right? It's in two separate pieces. Do you guys agree with that? So I'm going to have to treat it, each of these two pieces, kind of separately when I do the domain. So my domain's actually going to be consisting of two intervals, one interval for the first piece and one interval for the second piece. Everybody okay with that idea? Okay. So if I'm looking just at the first piece of this graph, the leftmost point is, the left arrow, so negative infinity. And the rightmost point is negative 1. Should that get a parenthesis or a bracket? Bracket. And we know why, right? Because there's actually a point there with x coordinate negative 1. Now let's look at the second interval. So the symbol that we use to connect two intervals is this like U with no tail on it. The name for that symbol is called the union. And it's basically the same thing as like an OR inequality. So you remember in Algebra 1 how you did OR inequalities sometimes? Where you had like the x satisfied by this inequality, or it could be satisfied by this inequality. It's the same idea here. It's just like the set version of it. So if I look at the other piece of our graph, the leftmost point on that piece is at 3, 0, or 3, 2, right? Now, what does it mean when I have an open point as opposed to a closed point? Do you guys know what that means? Okay, so recall back to like when you graphed an inequality on the number line, like say x is less than 2. For that sort of a problem, you put an open circle at 2 and drew it to the left, indicating that 2 was not a value that's satisfied by that inequality. You remember doing that in your algebra or pre-algebra class? As opposed to if you had x is less than or equal to 2, what did you use there? A closed circle, right? Where you did that. You guys remember doing that in your algebra or pre-algebra classes? We're borrowing that same notation here. So the open point, 3, 2, indicates that the graph goes right up to that point, 3, 2, but that point is not included in our graph. Just like when we drew the open circle on the inequality, that 2 wasn't included in the things that are satisfied by that inequality. So what that open circle is telling me then is that instead of using a bracket here on the 3, I should use a parenthesis, because there is no point there at 3, 2. The graph goes right up to it, but there's not actually a point there. Is that okay with everybody? So we just borrowed some notation that you're already familiar with, that you're like, oh, okay, sure, is that what that means? Same thing? Okay. Good. So the rightmost point then would be positive infinity. So far, so good? So again, as in inequality, that's what that interval is really saying. I'm going to move this down here so I have a place to do the range over here and not have to erase it. That's why OneNote rules, because I can just pick up and rearrange my notes without having to actually erase anything. All right. So again, we're going to do the same thing now for the range. We're going to work at this piece by piece. Everybody's okay with that? Okay. So for the first piece, the leftmost part of our graph, what is the lowest point? Negative infinity, because we have the arrow pointing down. And the rightmost piece of our graph is -1, because I have the y-coordinate there at that point. Now the -1, should I get a parenthesis or bracket? Bracket. And then we use that union symbol. And then I look at the next piece, or the other piece of my graph. What is the lowest point on that piece of our graph? It's the point 3, 2, so the y-coordinate is the 2. Should that 2 get a parenthesis or bracket? Parenthesis, because it's an open point rather than a filled-in point. And the highest point on that section of our graph is positive infinity. We feel pretty good on doing these. Something like this is as hard as I would ever make it for you guys, which I think this is amply tricky enough. So I think that should be enough that you guys could complete that first homework assignment. I think, what was there? There's 10 relations on there. They ask you if they're a function or not, and then to write the domain and range. So should be able to do that now. Yes, sir. So I might have things that I need to update, and I will do that along the way. So far, we've only gotten through enough to do one, yes.
So the only thing we do on Sunday is not until
At this point, yes. I don't know how much, we're still going to continue on and do some more stuff today, and I don't know that whatever we finish today, maybe there's enough for the next assignment, maybe there's not. I'm not sure yet. But I will have that all fixed by the time, we leave school today. So that is reflecting correctly what's going on. But yes, thank you for pointing that out. Again, you write some plans on Monday, what you think you're going to get through, and maybe that doesn't quite happen. And that's okay. Like, I'm not in a rush to get through all of this stuff. So that's fine.
how long do we have to do that?
How long do I have to do what? No, I'm gonna continue doing some more stuff right now. Is that okay? Okay. Yeah. Just to be so we're all on the same page, clear here. All right. So we've been talking about sets, and then we talked about a certain kind of set called a relation, and we talked about a certain kind of relation called a function. What we want to do now is we want to be able to talk about some of the ways that we could describe a function. So if we have two functions, we could kind of compare and contrast them. Okay with that idea? So we want to develop a language of attributes that functions have that we can use to describe what they look like and be able to compare and contrast them and talk about the features of them or whatnot. Everybody okay with that plan? Okay. So we're going to talk about two of those ways here. The first way is where the function is positive, negative, or 0. So we say a function is positive when it's above the x-axis. We say it's negative when it's below the x-axis. And we say it's 0 when it's on the x-axis. So an example of this, typically when we do these kinds of problems, I'll give you a graph. Okay, so my first question, let's just kind of look at how many sections of the graph do you see that are positive? Remember, positive means above the x-axis. I see two sections of the graph that are positive. I see this section here, and I see this section here. Is everybody okay there? Okay. So let's look at that positive part of our graph that's most on the left. So the hump part. What is the leftmost point on that section? -3, 0, right? So when we describe where something is positive, we're always going to be describing it using its x-coordinates. So we're going to start with -3. And then what's the rightmost point on that hump section? 0, 0. So the x-coordinate is the part I care about. So we're going from 3 to 0. Now, if I look at that point, negative 3, 0, is that point above the x-axis? No, that is on the x-axis. So that should not be included with the positives, right? So I'm going to use a parenthesis there. How about the point 0, 0 where it ends? Is that above the x-axis? No, that's on the x-axis. So that should not be included either with the positives. So that's going to get a parenthesis. Is everybody okay with that? We'll do an example here in a moment where maybe that wasn't the case. Okay, and then we're going to use that union symbol like we did with earlier to connect it with the other section of the graph. So if I look at the other section, the leftmost point is 2, 0, but the x-coordinate is what I care about, so just a 2. And the rightmost point on that section is the arrow to the right, so positive infinity. Now we know the infinities always get a parenthesis. How about the 2? Should that have a parenthesis or a bracket? Should have a parenthesis because the point 2, 0 is on the x-axis, not above it. Is everybody so far so good? Okay. Let's do the negative parts now. How many sections of the graph do you see that are negative? I see 2, right? I see this section here, and then this section here. Everybody agree with that? So same idea. We're going to describe the x-coordinates of where the graph is negative. So that first green section, the leftmost point is, it's the arrow pointing down, or the arrow pointing to the left and down, so negative infinity. That's correct. And the rightmost point on that section is negative 3, 0. So the x-coordinate's what we care about. But now we have to ask ourselves, is that point negative 3, 0 below the x-axis? No, so it's not below, so we should use a parenthesis. Remember, negative means below the x-axis. That's why I asked, or why the question changed from above to below. Right? Positive is the above, negative is the below. Okay, let's move to the next section. That little valley or whatever. Where does that section start at? The point 0, 0, but the x-coordinate's what we care about. Now, should 0 get a parenthesis or bracket? Parenthesis, because the point 0, 0 isn't below the x-axis. And then where does that valley section end at? 2, 0. The x-coordinate's what we care about. Should I use a parenthesis or bracket here? Parenthesis, because 2, 0 is not below the x-axis. So far, so good? Okay, how many places do you see where the graph is on the x-axis? 3, right? Here, here, and here. You guys agree with that? Notice, though, this part of the graph that is on the x-axis is finite, right? There's exactly 3 points that are on the x-axis. So the notation that I'm going to use is just going to be a list. So I'm just going to list the x-coordinates for those 3 points. Negative 3, 0, and 2. Is everybody okay there? Let's do another example that's a little bit trickier. Okay? Just so where maybe the bracket and parenthesis thing comes into play a little bit more. Okay? Ooh, excuse me. Wednesday felt like Friday to me. Thursday felt like Friday to me. Today feels like Friday to me. This feels like a 7-day work week. Okay. Let's start with the positives. How many positive sections do you guys see? How many positive parts of this graph do you see? I see two. I see two parts that are above the x-axis. I see this part right here and this part right there. Is everybody okay with that idea? Okay. So for that leftmost positive section, what's the leftmost point on that section? Negative 5, 4. So the x-coordinate's what I care about, so negative 5. Should I use a parenthesis or bracket here? Is the point negative 5, 4 above the x-axis? Yes. So I should get a bracket. Okay. What's the rightmost point on that section? Negative 3, 4. The x-coordinate's what I care about. Now, should I use a parenthesis or bracket here? So I've heard one person say bracket, I heard one person say parenthesis. So you might think we use a bracket because that point is above the x-axis. But is there a point there? No, because we used an open circle instead of a closed one. So even though that is above the x-axis, there is no point at negative 3, so it still needs a parenthesis. Everybody okay with that idea? That the open and closedness supersedes the location of whether it's above or below or on. Okay? Again, I told you there was going to be a trickier one. That's one of the things that was tricky about it, right? Okay, let's move on to the other positive section that begins at the point. 1, 4. The x-coordinate's what I care about, though, so we'll write a 1. Should I use a parenthesis or a bracket? Bracket, because that is a filled-in point that is above the x-axis. It ends at what point? 3, 5. The x-coordinate's what I care about. And should I use a parenthesis or bracket here? Bracket. That's supposed to be filled in. I know it looks like there's a little white space in there, but I meant to fill that all the way in, if you couldn't tell. Everybody's okay there? Let's do the negatives then. How many negative sections do we see? Just one. This one right here. Where does that negative section begin at? 3 comma negative 3, but it's the x-coordinate that we care about. Should I use a parenthesis or bracket here? Parenthesis, because it's an open circle. Even though that point is below the x-axis, the open and closed circle part supersedes the location. Where does this negative section end at? 5, negative 3, but the x-coordinate's what we care about. And shall I use a parenthesis or bracket here? Bracket, because this point is located below the x-axis. And that's all for that. And then we have the zeros. Okay. How many places do you see that the graph is 0? Well, there's one section, right? Notice that this section is infinite, unlike the previous example where the zeros were finite because there were just 3 points. Here I have an infinite number of points in between those two endpoints, right? All right. What's the leftmost point on that 0 section? Negative 1, 0, but the x-coordinate's what I care about, so I'll write the negative 1. Should this be a bracket or a parenthesis? Should be a bracket, because that point, negative 1, 0, is on the x-axis, and it is filled in. Where does this 0 section end at? 1, 0, but it's the x-axis, or the x-coordinate that we care about. Should that be parenthesis or bracket? Parentheses, because it's an open circle. That supersedes the fact that it's on the x-axis. Yes?
How is that infinite?
Because there's an infinite number of points on that segment, right? You have like negative 0.90, negative 910, negative, like there's infinite number of points on that section, as opposed to this one where there was exactly 3 points that are on the x-axis. So even though the endpoints aren't infinities, there is still like an infinite number of points in between them. Okay with that?
Yeah.
And again, if I use that vocabulary and you're not sure, please ask and we can clarify, because I'm sure you're not the only one going, wait a minute, why is that infinite again? And that's okay. I'm glad you asked. Let's stop here. We have 15 minutes left, but this feels like a good stopping point. I don't want to overwhelm anybody with more than they really need to